some kind of foul language like it's a motherfucker. Okay. However, the censorship broke it out. So they use grassroots horse in alphabet and use their communication in the forum. However, their censorship also broke it out. So I'm now trying to forward this cholima to you guys. Okay.
Side wants it.
Wants it? Oh. Yeah. Hopefully you like it. But don't do this. Don't speak like that to the Chinese. Okay.
Okay. So part of the thing that people generally want to do when they're in China is they want to get around the Great Firewall. The thing is that I want to make it, we're giving a talk about China, but I want to be kind of clear. This applies basically to everywhere in the world, including the United States. Depending on where you are, there's some guy sniffing the network or some girl sniffing the network, and they're going to do some nasty stuff. So we have a couple things we need in order to be resistant to these types of censorship attacks. And one of the things that Anthony talked about was the idea of detection, right? So like you have a keyword it goes through, and when you have this keyword on the network is able to sort of detect and react to you. So one of the things you want to have is confidentiality. If you don't have confidentiality, it makes it really extremely easy for someone to especially if they're on the local network, they can intercept anything and they can send resets. They could be much better. They could imitate your TCP stack better. They could imitate your DNS responses better. Depending on the type of attacker, it's kind of varying. So if you're on a backbone, you have a different kind of capacity and you have a different sort of memory, so to speak. But if you're on a local network and you have a very small segment, then there's almost no limit to what you can do. So it's important to not trigger that. So you want confidentiality. And you also want to make sure that when you send a request, the receiver of the request knows that it's exactly what you sent. And so you need integrity as well. And of course, since TCP/IP is, about as open as you can get, you need to make sure that you don't directly connect to the thing that you want to connect to, because if you do that, there's a pretty good chance that the thing you're connecting to, if it's high profile, like for example Facebook or Twitter or something like this, its actual IP addresses for whatever services that they use for hosting their website, those IPs will actually be in the block list. And so you want to have an intermediary in between. So the idea with Tor is that we sort of provide all of this and then some accidentally as part of being an anonymity system. So I guess some of you have probably used Tor. Any of you? Yeah? Okay. Who here has never used Tor, I guess is the question. Just like one guy. One guy in the corner? Two guys? All right, cool. Sorry it's slow. How fast do you want to die? So Tor, basically, if we were to go through it, it would take quite some time. There are hours-long lectures where we can talk about circuits and we can talk about cells and we can talk about the crypto and stuff like that. But in short, it allows you to do most of the things you want to do on the internet anonymously, where you get all of these things that I was previously mentioning, right? You want these different properties. You want a lot more than those properties, but those are the most important ones. So you can make DNS queries through Tor, but you don't get the ability to make arbitrary UDP packets. So there's a big difference, right? We have a DNS port, which is like a DNS server, and you can make DNS queries, and those queries will allow you to connect to sites. So if you have to deal with DNS blocking, you can just use Tor for your DNS. If that's the only filter, and if you don't care about anything else, it will transport your DNS requests just fine. And there's a guy who's here, his name is Colin Milner. We've been working on this project called TTDNSD, and it allows you to make arbitrary DNS requests through Tor by making TCP connections to recursive DNS servers that are upstream, and it uses the Tor network first. And that means that if you're only worried about DNS blocking, you don't have to worry about Tor being slow, because you can do all your DNS resolves and then just connect directly. And unless the IP address is actually blocked or the content of the messages you're sending are blocked, you can sort of do a hybrid thing to get around some kinds of filtering. Anyway, in short, the way that Tor works is that you have this large network. It's essentially a peer-to-peer network with a series of directory authorities. All of our directory authorities are, of course, blocked in China. So at the moment, a client in China actually has some amount of trouble connecting to the Tor network. So we'll get to that. So the 60th anniversary of some guy making this country, the PRC, happened recently. And when that happened, they blocked the Tor network. So what they did is they downloaded a list of relays which is the directory authorities give out a list of relays. That's how clients make routing decisions. It's a source-based routing protocol. So the source says, I want to route through 3 hops. These are my 3 hops. It builds a circuit. There's cryptographic handshakes that happen in each step of the way, so you know who you're talking to is who you think you're talking to. And the problem is that if you can't get that list, you can't build that circuit and you can't make your connection. So what the Chinese government did on the 60th anniversary, or 5 days before, is they downloaded that list and tossed it into the Great Firewall. So now we have this problem, which is that if you want to connect directly, you need a new intermediary. You can't just use the normal Tor network as your intermediary to connect to, for example, Facebook or Jabber or whatever you want. So it's a problem. Like all that crypto, all that integrity and confidentiality you got, it's totally like it doesn't matter because you're blocked. So we can't solve this problem very easily in that you have 2,000 IP addresses, which you have to give to everyone so that they can use this system to be secure. And if you don't give those IP addresses to everyone, you have a partitioning problem, which means that you can give one section of the network to one person and one section to another. And you can't do that in an anonymity system, because if you do, you start to be able to partition users' behavior, and you start to be able to potentially de-anonymize them. So instead of partitioning, what we did is we came up with this idea, which is called bridges. And I'll get to that in just a second. But first I want to talk about single hop versus multi-hop. So part of the reason that you want to have multiple hops when you're using the Tor network is that you don't want to have a privacy by policy system. So if any of you use a VPN, you know that what you're basically saying to the VPN provider is, okay, you know who I am, you know where I'm connecting from, and you know everything I do online, but you promise you won't write it down. Okay, you wrote it down, you promise you won't tell anyone. Okay, you shared it with your critical business partners, but you won't share it with, like, I don't know, law enforcement or someone that breaks into your systems. Okay, you share it with them for like specific things, and like you see this path where it goes, and we want to build something stronger than that, because even if the proxy operator is 100% honest and everything is totally solid, they can still be monitored, right? Every machine on the internet is near another one that can be compromised. So you want to make sure that you are not using just a single hop, and you also want to make sure that your traffic is mixed with other people so that it's extremely difficult to sort of like decide which traffic is the most interesting. And hopefully that can be helpful to you. And the way that Tor tries to avoid this type of surveillance is that we know that there's a correlation attack, which is that incoming traffic and outgoing traffic can be correlated, and then you can de-anonymize someone. So if it's just a very small network, like a VPN provider, that's trivial. If it's a global network that spans every country in the world, that becomes very difficult to block and very difficult to surveil. And even if every country was cooperating legally, it's still technically very difficult, but they're not cooperating legally, so it's also very socially very difficult. So bridges are how we solve the Chinese blocking problem. This is also how we solve it in Iran and in a number of other countries. And you know, I'm pretty happy to say, and kind of proud, most of the bridges that I've seen are actually run by Americans and Germans. There are some people from Sweden, a lot of people from Sweden actually, that run relays as well. But most of the bridges that I've seen are actually in the United States and in Germany, which is pretty awesome. I mean, people here really care about free speech. It's very inspiring to see that. So what a bridge is essentially a relay, just like the relays that are in the directory authority. So you can do cryptographic operations with them, and you can send them data and build circuits and attach streams. But the difference is they're not in the directory at all. So they don't exist, basically, as far as anyone else is concerned. So you need to connect to the Tor network, but you don't want to have a privacy by policy system. So what you do is you connect to a bridge that maybe I run for Anthony. Like if I ran one in California, I don't tell anybody about it, but I tell him, maybe by communicating with him in some other way, over chat or something. He can connect to me, but he doesn't want to trust me with all of his sensitive information, so he connects to me, and then from that, Tor automatically uses that bridge to bridge into the Tor network, and now he's in the Tor network, and he doesn't have to trust me, and the Tor network doesn't know he's coming from China anymore, so it's extremely difficult to target him. So, interesting thing here is that when these blocking events happen with China, they harvest this information. So we have two types of bridges. We have public bridges and private bridges. Public bridges are essentially just like relays, except instead of going to a directory, they go to what's called the bridge authority or the bridge DB. And we have a website, bridges.torproject.org, which will give you bridges. And the way that works is that we have this hash ring, essentially, and if you are coming from a certain set of IP addresses, you're in one section of the hash ring. And if you are sending an email to bridges@torproject.org, you again enter the hash ring in a different position. And every time you make a request, you enter in the same position, so you always get the same bucket of IP addresses. So no one party can easily harvest the entire hash ring of data. I mean, it is of course possible, for example, if you have like 10,000 Gmail accounts to send 10,000 requests and get them. But what we're doing is offloading that work so that they have to break Google's CAPTCHA instead of some CAPTCHA that we spend months engineering or something. So it's possible, but it changes it a little bit. It makes it a little bit easier for us. So like the Tor network is one geographic location, and China is another geographic location. And of course, the interesting thing is the public bridges have actually all been harvested. So on a regular basis, people go to bridges.torproject.org and bridges@torproject.org, and they get all the bridges and put them into the Great Firewall. So they're actively harvesting things that take a great deal of effort to try to block access to the Tor network. And actually, at the moment, unless you have a private bridge, there's a really good chance that you can't use Tor in China right now, which is really extremely disappointing. But it's not because of protocol filtering. It's just because of IP port and IP address blocking in the firewall. So unfortunately, because they are able to adapt and to grab this information, it's sort of it's kind of a cat and mouse game. But we did take it from something we can never win, which is a public list that we give to everyone, and we reduced it to a private list that sometimes is given to some people, but in some cases, like private bridges, they're not given away at all. The private bridges always continue to work. The public ones don't. So some people will have access to this network, and some people won't because they're spending lots of someone's taxpayer dollars to do that. An interesting side effect of this is that when they harvest, so I run one of the Tor Directory Authorities, they connect to me, potentially, or to someone else, and they pull down that list of IP addresses. And then they put that into the firewall. Does anybody see a problem with that? Like, this is kind of a funny, like an unintended consequence here would be that if all of the Tor network decided to do this, all the directory authorities could, for example, put in the IP addresses of every place where you request a visa to leave the country, and then all of a sudden none of those sites work anymore because they're all blocked. Right? So there's a kind of funny thing here. When you know that you are the source of information for censorship, you can affect the outcome of that censorship. We have not done that, and I think it's probably not a wise thing to fuck with the bull unless you're willing to get the horns. But I guess those of you that know me know that I probably don't have a problem with that. So in the future, I can imagine that you might see something like that. Although I don't think the Tor project wants to do that, so it probably won't happen. But how much does what cost? Pay you off. To pay me off? Die in a fire. Sorry to all of those that have actually died in a fire. So here's the deal. If you run a bridge, you can actually help someone, right? You can help someone directly right now. I mean, I hate to sound like, the Save the Children woman or something, but, unfortunately, censorship is a really big problem, and it's not trivial to make it go away because it's socially very successful. A lot of people really believe that they should not have access to information, and they should not be able to make decisions on their own, and that someone else is better making decisions for them, and that they don't need autonomy or agency in order to make changes in the world. I say fuck that, straight up, right? If you're not clapping, I'm a little disappointed. And if you are clapping, you can run a bridge and you can also do this, right? It doesn't take anything special. It's a peer-to-peer network. It's as easy as clicking, an install and checking a box. And you literally help people. And while in some cases China is harvesting it, interestingly enough, the Chinese government isn't sharing their block lists with other countries. So everybody else has to reproduce this effort, which means that since they're not doing that, your bridge is still useful in a lot of other places like Iran or Canada or here or wherever you happen to be that does some sort of network censorship. Anyway, that's it. Check that single box, and you can do it automatically. And you have no liability. If you do this, they can only connect to the rest of the Tor network. So there's no harm that can possibly come to you unless Tor were to become illegal, which it's not going to. Thanks. Yep.
Jacob. In this last part, we'll be talking a little bit further detail on the technical operation of the Green Dam software that